In part 2 of our look at two-way tables, we're going to take a look at relative frequency tables, and also we're going to look at how to look for subsets of groups when we're analyzing a two-way table. So in this particular problem right here, we have our general two-way table. Again, we're comparing two different quantities, students age 10 to 13 and students age 14 to 17, against two other quantities, those that eat breakfast and those that skip it. We can turn this into a relative frequency table by following basically two steps. So the first is to turn it into a fraction. Now, you notice the second table here, it's got a lot of the same numbers. We've got a 40, a 14, a 12, a 24, a 47, and a 43, and those all appear in the table above. What they also have in common is that every single one of these fractions has the same denominator, which is 90. Now, if you noticed, that particular number, 90, was the total that we had here. So to create this relative frequency table, which in fractional form, we're going to take each of those numbers in the two-way table and divide by the total. But what we generally want to do is turn this into a percent, because that's just easier to compare everything. And so what we're going to do is take 40 divided by 90 to get it to 44. Basically, we're just going to take all these numbers and turn those into percents to get our values. So we have this one here. We've got comparing the number of males and females, and those taking Spanish, French, German, and no language. And we want to turn this into a relative frequency table. So again, I'm going to take each of these values in each of these boxes, and I'm going to divide by 300 because that's the total. So we want it relative to the entire. So to do the males who speak Spanish, we're going to do 42 divided by 300. And we end up getting 14%. Again, we're going to round to the nearest whole number, and that could become an issue later, and you'll see it in a minute. And French, we do 7%. German was 5%. None was 20%. And then our total is 47%. Do the same thing for the females for Spanish, French, German, none, and our total, 23, 6, 13, 11, and 53%. Now we know in total we're going to have 100%. That's always works out that way because it's everything all together. We're going to do the same thing for our totals here, and you'll notice I'm actually going to take 110 divided by 300, 40 divided by 300, and so on. And you'll notice we are going to run into a little slight issue. What I really want to call your attention to is this column right here, the none. So we had 20% of males didn't take any language. 11% of females didn't take a language either. I'm sorry, relative to the entire population. If we added these up, they should add up to 31%, but they don't. They add up to 32. Similarly, if we went this way and added them up, we don't add up to 47, we add up to 46%. The reason that's happening is all these numbers in here are rounded. So if we round every single one of these, our final number is going to look a little odd. But here's what we want to make sure of. We use this number right here to calculate this. Use this number right here to calculate this. Use the data in the table. Don't just add up the percents, because then things can be off a little bit. So what percent of students were enrolled in Spanish? So again, I think once you create the relative frequency table, it's fairly easy to analyze, and I think easier to analyze than a two-way table. Percent of students enrolled in Spanish, so we go to Spanish, is 37%. Percent of students who were female enrolled in German, so that's right here, 13%. Percent of students not enrolled in a foreign language class, so that's our none category, that's 32%. Percent of students male enrolled in French, let's see, male French, 7%. And the percent of students that were male overall is 47%. So again, that's how we're going to create a relative frequency table. Take each value in the box, divide it by the total, and then you'll have your percents. What we're also going to take a look at is it's called conditional probability. If this thing happens, then this other thing happens. We're looking to put them together. And when we look at it for a two-way table, we're basically trying to figure out, do we have an entire population or do we have a subset of population? So Mathletes is going to sell candy as a fundraiser. 80 students are surveyed. We got our two-way table there. A conditional probability is basically if we don't want to look at the entire population. If we want to just isolate, let's say, females or those that like peanut butter cups or whatever. It's not the entire population. The key is reading it and making sure we know what population we've got. So in part A here, it says, what proportion of students are male who like a lollipop? So students is the entire population. So in this case, our denominator will be 80. Right? Proportion of students means the proportion of everybody altogether. In B, it's a little different, though, because now we're looking for the proportion of male students. We're not looking at 80 anymore. There's a little typo here. It's not 45 either. The number of male students is 37. Again, if we have proportion, probability, percent of, the part that's right after that is going to tell us what size population we're looking for. Part C, what proportion of students? Again, 80, proportion of students. And D is where it gets a little bit tricky because the initial thought is, well, just students, so it's got to be 80, but it's students who like peanut butter cups. So we're saying this is the group that we're looking at first, those that like peanut butter cups first. Then how many of those are female? So in this case, our denominator would be 35. Whether we do probability or proportion, it's the same idea. We're looking for that value right there to tell us our denominator. So as we look at a couple examples here, we've got our table, and I think we've seen this one before already, our two-way table with Coca-Cola and Sprite and those cans in the recycling bin and left on the table. So what we're looking for here is to create the fraction. Or if it's a percent, we're going to do percent, but these are saying proportions and probabilities, so we're looking for the fraction. First thing we want to identify is what's our denominator, and we figure that out based on what is our sample group. So in 1b, it says what proportion of Coca-Cola cans. So we're identifying Coca-Cola cans is our group. So if we look at the two-way table here, Coca-Cola cans is 50. That tells me what my denominator is. Then I want to know how many were in the recycling bin. And so it's 34. Out of those 50 Coca-Cola cans. 34 of the 50 Coke cans were in the recycling bin, where they should be. Part B, what proportion of cans on the table? So we're looking for a different group now. Cans on the table. And so that is 30 were Coca-Cola. 16 of those. So our fraction then will become 16 out of 30. 3b, what's the probability a can in the recycling bin? So our first thing we're looking for is the recycling bin group. So that's 42. And it was a Sprite can, so 8 out of 42. Okay, so again, that first part will tell us kind of where it is. Now, we're not always going to give it to you in bold, so let's look at some that we have to do a little bit of interpretation on. Here we go. So we're back to this one about the Game of Thrones and sports team versus not on a sports team. And now we're looking at subgroups. Or maybe not. Maybe we're looking at the whole thing. We've got to read and determine that. So number 13 says, what proportion of students are on a sports team? So again, proportion of students. And I don't see anything like who or any other qualifier. It's saying are. That means that that's the second condition that's met. So proportion of students, so again, we're looking for all students, are on a sports team. I see 49. So my proportion there is 49 out of 99. 14, what proportion of those, okay, that sounds like we've got a little subgroup there, who do not watch Game of Thrones are not on a sports team. So all that stuff right there and that's highlighted in blue, that's what we're looking for first. Those that don't watch Game of Thrones, there's 48 of those. Those that are not on a sports team, 32 of those 48. So our proportion is 32 out of 48. And 15, what's the probability that a student not on the sports team? Okay, here we go. Probability, student not on a sports team. So that's what we're looking for first. Those not on a sports team, it's 50. And then watches Game of Thrones is 18. So our probability, really it's a proportion, same thing, 18 out of 50. Okay, so again, that is looking at a relative frequency table, and also how do we look at those subgroups.